Okay, so let's continue with the tension. So here tension means it is the force developed in string, rod or chain. Okay, see, this is a hanger, this is a rigid support. To this rigid support we have tied with a rope or a string, whatever you can call it. So to the string downside we are connected with a body of mass m. Okay, it can be sphere or anything. Okay, so in gravitational force earlier we have discussed, always gravitational force acts downwards by virtue of its mass. Okay, right? So always one force acts downward, that is what, mg. Since it is not kept on any surface, there is no normal reaction. But instead of that, what is one more force is there which is making this body to stand stiff here, that is the force which is there inside the string, that is nothing but our tension. Okay, so when you hung a wire, so downside by virtue of mass mg, that is towards the center of the earth, and in upwards, that is tension, it will be there. Okay, so if you take here mass which is there on a surface, and you tied it through a rope and you are pulling it, let's assume here like this. Okay, when you are assuming you are applying force at this point, but body is being moved away, but who is applying force here? That is the force which you are applying is been transferred throughout this. That force is nothing but the tension force. Okay, the tension is pulling this body. Okay, and similarly if you consider this example here, what you are doing is these two bodies you have kept alongside and tied by one more rope, and here you are pulling it with the another rope, second rope. Okay, so you are applying force here. Here m1 and m2 both are moving. So what is this body, why this body m1 is moving? This is the force developed in this string, that is tension in this string. And why this body is moving? This is due to the force exerted or there between this string. Okay, that force we call it as tension. Okay, now you understood where tension is there. Okay, now coming to its symbolic representation and sign. See, here always we use called chata concept or umbrella concept, we call it as. So what is direction of the tension? Direction of the tension will be, so here downside mg will be there. So if you are calculating here, go open your umbrella in upward direction, the tension will be there. Okay, what is the tension here? Direction tension will be, and if you are standing here, you open your umbrella will come like this, so your tension direction will be like this. So string is same only, so the tension throughout the tension throughout the wire will be same. If your tension T is here, and here also we can write it is at a tension T only. Okay, and here it is mass m. Okay, so you are applying force here. Now what is the direction of the tension here? So the body is being pulled, so from contact here it is there, open your umbrella towards this direction, so what will be the direction? So it will be like this, tension, it will be like this. Okay, and if you are applying force here, what is the direction of tension at this point? Open your umbrella and umbrella opens here, this will be the tension. So the same rope will be there, that's why the tension remains same, that is T only. Okay, and now coming to third example here. So here you are applying force here. Okay, what is the direction of the tension? Tension, you open your umbrella opens like this, this is the tension T. Okay, and what is the tension direction here? You are applying any force here. What is the tension here? This from this direction, it will be like this, that is tension T. Okay, so from here to here only one rope is there, so I will write it as T. Okay, now when it comes to here, the rope changes. When rope changes, what happens? Tension also will change. Okay, so but however, throughout this cross section, throughout this wire, entire length of the wire, tension will remain same. But when you compare this tension with this, the value will be different. Okay, now what is the tension direction here? From if you open the umbrella opens here, there is the tension. Should I write T only? No, it should be different notation, that is T1. From here, if you keep it, tension, it is T1 like this, right? So this is the notation of tension. Okay, so use chata concept or umbrella concept. You open the umbrella opens like this, this is the direction of the tension. Okay, let's take one more example here. Okay, so I have hung a mass m. You can clearly see this. I have hung a mass m here. Okay, one with rigid support here, the other one rigid support with this one. Okay, so the body has mass m. Okay, now if you see, okay, and it is given that the string is massless string. Okay, from this particular point, if you open the string opens, I mean umbrella opens here, this is the tension T, T1. Let's take, why? Because two different types of ropes are there. Okay, T1, from this point tension difference, the same tension will be there, that is T1 acting in this direction. If you come here, open the umbrella, umbrella opens in this direction, that is T2. And if you come here, rigid support, if you open the umbrella, that is T2. So T1, T1, T2, T2. So this is the direction of water tension. Now if I ask you, what is the direction of the gravitational force due to this mass m? The mass m is here. So if you draw this, the mass mg is somewhere here. So this is the direction of force is always acting toward the center of the mass. So these all are all the directions of tension. Now, so we have discussed two things in the previous section, that normal reaction as well as, and now tension. So here are the two questions. One is to draw normal reaction, and here other one to draw, to draw tension here. Okay, let's go for this particular diagram. So this diagram is nothing but your inclined plane, and on this inclined plane a block B is kept, and the other side of the block is attached to this rigid support. Okay, now let's calculate all the forces. Normal reaction. What is normal reaction? I said normal reaction means you know it very well. So if you have a body mass like this, it's a rigid support. If you keep a body of mass m like this, a mass m like this surface exert a force, normal force on this, and in turn this body exert a normal force downside. Okay, right. Now coming back to this problem. Now what happens? What exactly it says? It says now here normal reaction is going like this. This is the inclined plane is acting, it is exerting a normal reaction onto this block like this. Okay, in turn this block is also exerting a force, that is normal force, that is counter force exactly downside, that is this one. This is, let us call this a normal one n1, and it is n1. So these are opposite in direction. So this is one normal reaction force. Okay, whenever the surface in contact is there, we find normal reaction. So one surface contact over. Now see this surface contact. Now again in the surface contact, this body that is block B and surface is there. So this block, this surface is exerting a normal reaction n2 perpendicular to the surface n2, right? And in turn this block is also exerting a force onto the surface opposite in direction, that is n2 over. So this is one normal reaction, and it is another normal reaction over. Next, come to this one. This inclined plane is exerting, it is kept on this rigid support, ground. So ground is exerting a normal reaction onto the inclined plane. Let us call this as n3. Okay, and this inclined plane is exerting a counter force, that is normal reaction again downwards like this. It is n3. So wherever the surface are in contact, their normal reaction comes into picture. So this is n1 n1, n2 n2, n3 n3. So this is the normal reaction in terms of this. This one example is over. Okay, now similarly another example for tension. Okay, so let's see tension here. So the same mass m1, here m2. This m1 is tied to this rigid support, this m2 is tied to this rigid support, and to this one through two different strings. Okay, now you are asked to find out the draw the diagrams, tension acting in the strings. Okay, now how to draw it, you know it very well. You come here, open the umbrella, the direction of umbrella opens like this, call this tension as T1, right? And come back here and open the umbrella, umbrella opens here, call the same tension as T1. Why T1 T1? It is because tension throughout it is same only. Okay, so tension throughout the same, tension same means, sorry, string same means tension same, right? Okay, now come back here, open the umbrella here, umbrella opened. Okay, tension, let's take it as T2, and come back and open the umbrella toward this side where exactly the body is there. From there you have to open the umbrella. Okay, this you opened the umbrella, tension is T2, right? From here it is T1, here it is T2. Now come back here, open the umbrella. If you open the umbrella, it is T3, right? If you come back here and if you open umbrella, it is T3. So why I given T3 T3, you know very well. Why? Because throughout this, from this point to this point, the tension remains same, that is the tension same. From this point to this point, the same tension, so that's why it is T2. So this is regarding the tension. Now coming back to an important concept, that is free body diagram. Now in all these examples, so be it this example, this example, this example, whatever the examples that I have explained earlier, you have drawn the somewhat say a pictorial representation of the body, not exactly the exact picture, but at least in a schematic way you have drawn it, right? but we cannot do all the time the same kind of diagram and keep solving the problems. But instead, what happens, we need to go for some different kinds of procedures for that. A technique we have to follow it. That the technique we follow in solving these kinds of problem, we call it as a free body diagram. What is that free body diagram we call it? Where do we use is to, it is the main purpose of free body diagram. In short, free body diagram is also called as FBD, is used to reduce the pictorial representation, simply in a normal sense to explain, to instead of drawing too much of bigger images or drawings, go for a smaller, and in that pictorial representation what is actually is there is to mention total number of forces exerted onto it. Okay, that we have to draw it. That is what the basic idea of the FBD, that is so nothing but free body diagram. But we cannot simply follow it like that. There are certain rules to follow it. The certain conditions are there, we need to follow it.